This is the lesson for section 4.2, solving quadratic equations by graphing. As you can see from the cut out, the clip from our textbook, the solutions of a quadratic equation are where the graph of the quadratic crosses the x-axis. So in the diagram on the far left, the graph is tangent to the x-axis at the vertex, a single point, so the graph has one solution. In the middle graph, the parabola crosses the x-axis in two places, so this has two real solutions. And in the far right, the graph opens up above the x-axis and will never cross the x-axis, so there are no real solutions. And that's the three outcomes you can have when you solve a quadratic equation by graphing or algebraically, but here by graphing. So a quadratic equation, of course, graphs as a parabola. The parabola can open up or down, but it can either intersect the x-axis in a single point, the vertex, and you have one real solution, like the far left diagram, or it can intersect the x-axis in two places, opening up or down, so that would be two real solutions, or it can open up above the x-axis where there are no real solutions, or open down below the x-axis, and again, no real solutions. And the solutions are the same as what you think of as the x-intercepts, but specifically, it's the value of x where the graph crosses the x-axis. So in the problems 1, 2, and 3 below, when I look at the first problem, this parabola opens up above the x-axis, and as a result, there are no real solutions. In the second graph, it crosses the x-axis in two places at -2 and +5. So there are two real solutions, and they are -2 and +5. And in the third graph, it crosses the x-axis, or it's tangent to the x-axis at its vertex, which is -1 to -4. And so there's one solution, -4. In problem 2 and 3, this is the value of x for which we have a solution. So x equals -4, or x equals -2, or x equals 5. Now, let's solve the quadratic equation by graphing in number 1. This will be like the problems on your homework. So we're going to graph like you did in the e-learning. We want to start by identifying the values of a, b, and c in our quadratic. And of course, we have the quadratic set equal to 0, so there's no y in the equation, but the y would be where the 0 occurs in standard form. So in our equation, a is 1, b is 6, c is 8. So to find the x-coordinate of our vertex, we take the opposite of b, so that would be -6 over 2 times a, that's 2, and -6 divided by 2 is 3. So the x-coordinate of our vertex is 3, so we know here the vertex has an x-coordinate of 3, and then we have to find the y-coordinate, and we do that by plugging the 3 into the equation for x. So y is going to equal 3 squared plus 6 times 3 plus 8. Of course, that would be 9 plus 18 plus 8. So that, oh, you know what? I just realized, oh, this is a -3, okay? My mistake. So we're plugging in -3, and that means this is -18, and so that would be -9 plus 8, which is -1. That makes much more sense. So what we want to do is put the vertex value in the middle of our table of values. And then we want to test two values to the right and two values to the left of the vertex. So in the column for x, the two values to the right of 3 would be 4 and 5. And the two values to the left of 3 would be 2 and 1. As long as we're equidistant on either side of the vertex, we're going to have symmetry. So for instance, if I plug in, oh yeah, and this is -3. Let me go back here and fix this. Because it's negative, the two values to the right are -2 and -1, and to the left are -4 and -5. So if we test, let's say, -2, when we square, that would be 4, plus 6 times -2 would be -12. So 4 minus 12 is -8, plus 8 is 0. And theoretically, this should be 0 as well. And then if I plug in -1, -1 squared is 1, plus 6 times -1 is -6. So we'd have 1 minus 6, which is -5, plus 8 is 3. I just don't have room to do that. And so those are the points on my graph. And so now, to graph my equation, I'm obviously going to graph my points. -5, 3. That would be here. -4, 0, which is obviously a solution because that's where y is 0. -3, -1. -2, 0, another solution because that's where it crosses the x-axis. And then -1, 3. So I can see with my table where those solutions are. If y is 0, you still get to graph it though, to practice graphing. But the solutions here are the values of x for which the graph crosses the x-axis. And that would be -4 and -2. And your table confirms that because that is where y equals 0. Sometimes you can see it, sometimes you can't in the table. All right, we're going to try one more. This time in our equation, it is not in standard form. So we first need to get our equation in standard form. Now, we can take everything to the right side or to the left side. It really doesn't matter. What's going to change is whether the parabola opens up or down, but where it crosses the x-axis will be the same. So I'm just going to add x squared to both sides and then write it in standard form. So I have x squared minus 6x plus 3 equals 0, which means a is 1, b is -6, and c is 3. So when I plug in, the opposite of a -6 would be 6 over 2 times a. That's going to give us a positive 3. And then if we plug into our standard form, y would equal 3 squared, or 9, minus 6 times 3, which would be 9 minus 18. That's -9. And -9 plus 3 would be -6. So our vertex is at positive 3, and then we said -6. So in my table of values, here's my vertex, 3, -6. Two values to the right of 3 are 4 and 5, and two values to the left are 2 and 1. And as long as they're equidistant on either side, we do have symmetry. I'm probably going to plug in 1. 1 squared is 1 minus 6 times 1. So 1 minus 6 is -5 plus 3 is -2. That means 5 is paired with -2. Then if I plug in 2, 2 squared is 4 minus 6 times 2 is 12. 4 minus 12 is -8 plus 5 is -5. And notice how all my y outputs are negative. So that means all those points are below the x-axis. So if I move this up slightly, 1, -2, 2, -5, 3, -6, 4, -5, and 5, -2. Now I project that I'm going to cross the x-axis somewhere there and probably there, meaning my solutions are right here and here, which means they're between two integers. Now, I could actually check this if I want to add some more values to my table. If I add 6 in my table, 6 squared is 36, minus 6 times 6 is minus 36, that's 0, plus 3, and that has to mean at 0, if I move it slightly up here, I would be at positive 3 as well. And so here's what I want you to recognize. When you look at your y values in your table, they're all negative, between -2 and -2. You see that, but then we get a positive value in here. Hold it. That was 3. So we get a positive value in here. So if y is negative and then it becomes positive, you have to have crossed the x-axis between the x coordinates of 5 and 6. And up here, it went from positive 3 to -2. Above the x-axis is positive, below is negative. So we had to have crossed the x-axis between 0 and 1. So as far as our solutions here, our solutions are not nice integer values. They are between, now I'm going to use b/w for between, so I don't have to write it out. They're between 0 and 1, and between 5 and 6. They're not specific integers, but they are the solutions of this equation. All right, that is our lesson. Please check Canvas for your actual assignment. And I think you have 4 graphs, and then there's 6 problems where, like the first 3 at the top of our PowerPoint, you just have to look at the graph and identify the solutions. Shouldn't be too hard and should reinforce what you were doing in the lesson for 4.1. All right, we'll see you on Monday. Thanks.